mathematicians. Today we're going to be learning about fractions and decimals, more specifically about ordering fractions, mixed numbers, and decimals by converting to fractions. To get us started, we have 7 over 12, 6/10, and 11 out of 30. Now, 2 of these are written out as fractions, so we're going to leave them alone. So 7 over 12 is a fraction, so we're going to just rewrite it. But 6/10 is written as a decimal. But we know that 6 is in the tenths place value, meaning that 6/10 is equivalent to 6 over 10. And then we have 11 over 30, which is already a fraction, so we're going to rewrite it as is, so 11 over 30. Now, we have 3 fractions, and because they're all in fraction form now, it makes it easier to compare, except the denominators are different, so we have to find the least common multiple between our denominators, 12, 10, and 30, to write equivalent fractions with the same denominator, making it easier to compare. So we're going to find the least common multiple between 12, 10, and 30. Our multiples of 12 are 12, 24, 36, 48, 60, 72, and so forth. Our multiples of 10 are 10, 20, 30, 40, 50, 60, and so forth. Our multiples of 30 are 30, 60, 90, 120, 150, 180, and so forth. Now, the smallest common multiple that they have is 60, which makes that our least common multiple. So that means we have to write 3 fractions with a denominator of 60 that are still equivalent to our original numbers. So, starting off with 7 over 12, in order to get a denominator of 60 here, we have to multiply the denominator by 5. Whatever we do to the denominator, we must do to the numerator as well. So if we multiply 12 by 5, we would have to multiply 7 by 5. Now, 7 times 5 is equal to 35, and 12 times 5 is equal to 60. So that means that 7 over 12 is equal to 35 over 60. Then we have 6 over 10. In order to get a denominator of 60, we have to multiply the 10 by 6. And whatever we do to the denominator, we must do to the numerator as well. So 6 times 6 is 36, and 10 times 6 is equal to 60. Finally, we have 11 over 30. In order to get a denominator of 60, we have to multiply 30 times 2. Whatever we do to the denominator, we must do to the numerator as well. 11 times 2 is equal to 22, and 30 times 2 is equal to 60. So, now we have 35 over 60, we have 36 over 60, and we have 22 over 60, and because we have the denominator of 60, that makes it easier to compare all 3 of these. Smallest one being 22 over 60, which is 11 over 30. Then we have 35 over 60, which is 7 over 12. And then we have 36 over 60, which is 6 over 10, which originally was just 6/10. And so that's our numbers in order from least to greatest. All right, so here we have another example. We have 2 and 1/5, we have 2 and 8/10, and we have 2 and 7 over 20. Now, 2 and 1 over 5 is already a mixed number, so we're going to leave it as is. Now, 2 and 8/10 is a decimal, so we're going to write it as a mixed number. And so we keep the whole number, and because 8 is in the tenths place, it's going to be 8 over 10. And then finally, we have 2 and 7 over 20, which is already a mixed number, so we're going to go ahead and rewrite that. Now, all these mixed numbers have a whole number of 2, making it difficult to compare. And all the fractions have different denominators. So in order to make this easier to compare, we have to find our least common multiple between 5, 10, and 20 to find out our least common denominator and write equivalent fractions with the same denominator. So we're going to find our multiples of 5, 10, and 20. Our multiples of 5 are 5, 10, 15, 20, 25, 30, and so forth. Our multiples of 10 are 10, 20, 30, 40, 50, 60, and so forth. Our multiples of 20 are 20, 40, 60, 80, 100, 120, and so forth. Now our least common multiple is 20 because that's the smallest multiple they have in common. So now we have to make sure all our fractions have a denominator of 20. Starting off with 2 and 1 over 5. In order to get a denominator of 20, we have to multiply the denominator by 4. Whatever we do to the denominator, we must do to the numerator. Now our whole number stays the same, but for our numerator, 1 times 4 is equal to 4, and for our denominator, 5 times 4 is equal to 20. Then we have 2 and 8 tenths. In order to get a denominator of 20, we have to multiply 10 by 2. Whatever we do to the denominator, we must do to the numerator as well. Now the whole number stays the same, but for our numerator, 8 times 2 is equal to 16, and for our denominator, 10 times 2 is equal to 20. Finally, we have 2 and 7 over 20. Now this mixed number already has a denominator of 20, so we don't have to do anything to that. And so now we're going to order our numbers in order from least to greatest. So we have 2 and 4 over 20, 2 and 16 over 20, and 2 and 7 over 20, making 2 and 4 out of 20 the smallest, and that is equivalent to 2 and 1 over 5. Then we have 2 and 7 out of 20, which we originally started with 2 and 7 over 20. And then finally we have 2 and 16 over 20, which is equivalent to 2 and 8 tenths. And that's our values written in order from least to greatest. So here we have another example. We have 5 and 3 over 5, we have 5 and 7 tenths, and we have 5 and 5 over 6. Now, 5 and 3 over 5 is a mixed number, so we're just going to write that. And then we have 5 and 7 tenths. Now, this is not a mixed number, but we know that it would have a whole number of 5, and because 7 is in the tenths place value, that means we're going to have 7 over 10. And then we have 5 and 5 over 6, which is just going to be rewritten as 5 and 5 over 6. So here we have 3 mixed numbers with the same whole number, making it difficult to compare, and each of which that has a fraction with a different denominator, making it difficult to compare as well. So we have to find the least common multiple between 5, 10, and 6. Our multiples of 5 are 5, 10, 15, 20, 25, 30, and so forth. Our multiples of 10 are 10, 20, 30, 40, 50, 60, and so forth. Our multiples of 6 are 6, 12, 18, 24, 30, 36, and so forth. Now our least common multiple is 30 because that's the smallest multiple they have in common. So now we're going to take our mixed numbers and rewrite our fractions so that all of which have a denominator of 30. Starting off with 5 and 3 over 5, in order to get a denominator of 30, we have to multiply the denominator by 6. Whatever we do to the denominator, we must do to the numerator. Now the whole number stays the same, but for our numerator, 3 times 6 is equal to 18, and for our denominator, 5 times 6 is equal to 30. Then we have 5 and 7 over 10. In order to get a denominator of 30, we have to multiply the 10 by 3. Whatever we do to the denominator, we must do to the numerator as well. The whole number stays the same, but for our numerator, 7 times 3 is equal to 21. And for our denominator, 10 times 3 is equal to 30. And then finally, we have 5 and 5 over 6. And in order to get a denominator of 30, we have to multiply our denominator by 5. Whatever we do to the denominator, we must do to the numerator as well. Now, the whole number stays the same, which is 5, but for our numerator, 5 times 5 is equal to 25, and for our denominator, 6 times 5 is equal to 30. So, now we have 3 mixed numbers, all of which have the same denominator. We have 5 and 18 over 30, we have 5 and 21 over 30, and we have 5 and 25 over 30. And the smallest one out of these is 5 and 18 out of 30, which is equal to 5 and 30 over 5. Then we have 5 and 21 over 30, which is equal to 5 and 7/10. And then we have 5 and 25 over 30, which is equal to 5 and 5 over 6. And that's our values written in order from least to greatest. So we have one final example here, and we have 3 and 75 over 150. We have 3 and 52 hundredths, and we have 4 over 7. So 3 and 75 over 150, we're just going to rewrite because it's a mixed number. Then we have 3 and 52 hundredths. Now this is a decimal, but because the last digit is in the hundredths place value, we're going to write it as 3 and 52 over 100. And then 4 over 7 is a fraction, so we could just rewrite it as 4 over 7. Now here we have 2 mixed numbers and a fraction, and because 4 over 7 doesn't have a whole number, that automatically makes 4 over 7 the smallest value. However, 3 and 75 over 150 and 3 and 52 over 100 have different denominators, making that difficult to compare. So we're going to have to find our least common multiple between 150 and 100 for our first 2 mixed numbers. Our multiples of 150 are 150, 300, 450, 600, 750, 900, and so forth. Our multiples of 100 are 100, 200, 300, 400, 500, 600, and so forth. And so our least common multiple here is 300 because it's the smallest multiple they have in common. So we have to take our 2 mixed numbers and write equivalent mixed numbers that have a denominator of 300. Starting off with 3 and 75 over 150, in order to get a denominator of 300, we have to multiply our denominator by 2. Whatever we do to the denominator, we must do to the numerator as well. The whole number stays the same, so we leave the 3. But for our numerator, 75 times 2 is equal to 150, and for our denominator, 150 times 2 is equal to 300. Then we have 3 and 52 over 100. In order to get a denominator of 300, we have to multiply 100 by 3. And whatever we do to our denominator, we must do to our numerator as well. So our whole number stays the same, but 52 times 3 is 156, and 100 times 3 is 300. Finally, we have 4 over 7. And because it doesn't have a whole number, we automatically know that this one is going to be our smallest number. And so then we have 3 and 150 over 300, and 3 and 156 over 300, making 3 and 150 over 300 the next value, which is equivalent to 3 and 75 over 150. And then finally, we have 3 and 52 hundredths being our largest number. And that's it for ordering fractions, mixed numbers, and decimals by converting to fractions.